Welcome back to Aurora Tech Channel. Today, I'm going to review the Longer RAY5 laser engraver. It has a working area of 400 by 400. Besides the standard features that come with the desktop laser engraver, this also comes with a touchscreen and it also supports Wi-Fi. I'm going to run through some engraving and cutting tests using just the touchscreen and the Wi-Fi web interface to see if this can work well without having to connect a USB cable to the computer. I would like to thank Longer for sending me this machine to review, and with that, let's get started. We have the gantry, the motherboard and touchscreen enclosure, 4 aluminum extrusions to form the frame, 3 legs, a 5-watt laser module, the power supply, safety goggles, and some tools. The assembly is very simple, so let's just run through it real quick. Step 1. Use these 4 extrusions to form the frame and grab the screw bag labeled Step 1. Align the extrusions like this. These two are the y-axis. The ruler should face inward and the numbers should face outward. For the one at the front, just follow the orientation of the logo. For the one at the back, you shouldn't see any screw holes from the top. I will insert an angle bracket and then secure it with one longer screw. Just finger tighten it for now and leave the set screws on the angle bracket. We will come back to tighten everything later. Do the same to all 4 corners. Okay, make sure the frame is aligned perfectly and flat. We can now tighten the screws and the set screws on the angle brackets. Step 2. Grab the gantry and slide it into the frame from the front. Step 3. Grab the Step 3 screw bag, 3 legs, and the touch screen. I will install each leg at these 3 corners. For the front left, the touchscreen enclosure will work as the 4th leg. Use 2 screws with washers to secure the leg at the corner. Do the same to the other 2 corners. Use the same screw to secure the right side of the touch screen. For the left side, secure it with the short screw at the extrusion screw hole. Take the spacer and a screw and secure it at the left side of the frame. This will work as a stopper to stop the gantry as this machine has no limit switches. Step 4. Grab the Step 4 screw bag and the belt. In this step, we will install the belt on both sides of the gantry. Let's start with the right side. Let the teeth side of the belt go over the top wheel, and then go under the rubber pulley wheel to reach the front of the frame. The other end goes under the rubber pulley wheel at the back and reaches the back of the frame. Use the screw and T-nut to secure the belt at the front. Go to the back and do the same to secure the belt, but this time try to pull hard and keep the tension in the belt and tighten it. Do the same to the left side of the gantry. Step 5. Install the laser module. Just use the thumb screws to secure the laser module on the X carriage plate, and then we will insert the spacers and the screw at the back. These spacers are only used to make the module stay better on the track, so don't over-tighten them or it will make adjusting the height of the module harder. Okay, the assembly is almost done. We can connect some cables, starting with the Y-axis stepper motor, followed by the X-axis motor, and then the laser module. Finally, the power supply. Let's turn on the machine. Before I start engraving, I will show you my new laser engraver setup. I used to always put a piece of thick plywood underneath to protect my table, but this time I will try to use a 400 by 400 honeycomb bed with a steel plate on the back. I will try it with a 2mm sample plywood that came with the machine. To set the laser focus, just use the cylinder to put it in the middle of the back plate. Okay, let's test out this touchscreen controller. Use the button to jog to the starting position of the plywood. I will assume the sample G-code files in the microSD card are using the bottom left as a starting position by default. We can also turn on the laser dot at the lowest power for better alignment. It seems I still need to adjust it to the lower left. I will go back to the control menu and jog the machine. OK, click the position button so we can save this position as the home position. I will try to move the laser module away from home and click the home button to see if it can return. OK, it is now homing and I think everything is working fine. There is another button here called H-Home, which stands for Hardware Home. Since this machine has no limit switches, this button is of no use. Let's go back to the main menu. Select Engraving, and there are 3 sample G-code files. I will try the compass in the middle. Press the position button one more time to make sure we start here. Let's draw the frame and see if the working area is within the material. It seems okay. Before I press this button to start, I will put on my laser tent and connect the fan duct to exhaust all the smoke outside. If you like this DIY laser tent, fan, LED light, and ducting, I put the links in the 3D printed adapter STL files under the description. Okay, let's start the job. This is a small compass vector graphic. It's using 3000 millimeters per minute and 50% power. These numbers are good for reference, but we will test out the different speeds and power later. Instead of connecting the machine to the computer using a USB cable, I will try to operate it using Wi-Fi and see if it can really get rid of the USB cable, just like how you would connect a smartphone to your Wi-Fi. Okay, this is the IP address of the machine. I will go to the computer and open this address in my browser. It uses the open source ESP32 web interface. We can jog the machine, use the terminal, manage the SD card, draw the preview frame of the selected file, and start the job, just like what we can do with a touch screen. Let's try to use Lightburn to export a G-code file, and then upload it to the machine using Wi-Fi. I will use this test file from my Laser Master 2 Pro to engrave at 5000 millimeters per minute and use different powers to see the results. Since we are not connecting the machine to the computer, we can just use any machine profile with the 400 by 400 working area and save this G-code file. Let's call this file Power Test. Go back to the web interface and select this icon to upload. Select the file and it's here. We can select it and let the machine draw a preview frame. It looks fine, so let's click the play button to send the job. Here's the result for different power levels at 5000 millimeters per minute. I think anything over 40% is usable. Generally, a 5-watt module is not that good for cutting, so let's try something thinner. I will try some cutting on this 2mm plywood, starting from 500 millimeters per minute down to 100 millimeters per minute, and see what the fastest speed we can cut through the wood is. I will save the G-code file like before, go back to the web interface and upload the file. Draw a preview frame and start the job. Using 350 millimeters per minute or slower at 100% power can cut through this 2mm plywood. With this honeycomb bed, the edges are very clean, even when I flip the board to the back. As you can see, 400 millimeters per minute almost cut through it, but we can't see the laser penetrate the wood at any point when using 500 millimeters per minute. Next, I will engrave a logo and cut it out using 6000 millimeters per minute for engraving and 250 millimeters per minute for cutting. It looks fine, so let's start the job. For engraving, I want it to be darker, so I should try a slower speed. For cutting, it looks pretty good, and with the honeycomb bed, the cutting is clean on both sides. Then, I will engrave a photo using 5,000 millimeters per minute and 100% power on a 3mm plywood, and cut it out using 200 millimeters per minute. The photo engraving result is nice, and the laser can cut through 3mm plywood with 200 millimeters per minute. Finally, I will try some cutting. I think the thickest wood this 5-watt module can cut is around 5 to 6 millimeters. I will use this 1/4-inch poplar solid wood board to do some tests. First, I will cut at different speeds with 100% power. I will try 150 millimeters per minute and move down to 75 millimeters per minute. Cutting this solid wood is generating quite a lot of smoke, but the tent and my exhaust fan are working pretty well, and there's virtually no smoke outside even if I open up the zipper and put the phone inside the tent. Unfortunately, this module cannot cut through this 1/4-inch solid wood in a single pass. However, when I flip it to the back, both 175 millimeters per minute can almost cut through. I think it can cut through at 100 millimeters per minute with 2 passes. Let's give it a try. As expected, this module can cut 1/4-inch solid wood at 100 millimeters per minute with 2 passes. Okay, after all these tests, let's talk about what I think of this machine, starting with the pros. The offline controller is really nice. It uses the same MKS laser control board as the Two Trees TS3. The touchscreen is as good as the Two Trees TS3, and the firmware of this Longer RAY5 is tweaked better, especially the ESP32 Wi-Fi module, which works flawlessly, and I don't have the connection issues I experienced with the Two Trees TS3. You can do everything you can do on the touchscreen using the ESP32 web interface over Wi-Fi, which is really convenient. I didn't connect the USB cable to the computer during the whole test, so I would say it can work offline completely without using the USB cable. The assembly is easy. The screw bags are labeled with step numbers, so you can't go too wrong in the few simple steps it takes to put this together. The laser module is in line with other 5-watt modules. It's good for engraving and some light cutting, but if you want to cut thicker material, you may need a 10-watt module. The good news is that Longer will have the 10-watt version available soon. The price of this machine is $339. If you buy a standard engraver without the touchscreen and Wi-Fi features, it will cost almost the same price, so I think this is a pretty good deal in terms of price and features. As for the cons, the Wi-Fi module works really well, but the hardware has its own limitations. The ESP32 module does not work that well for uploading large files. For example, some simple vector engraving files from a few K to a few 100Ks can be done in a few seconds, but if you upload a 5 megabyte photo engraving file with a few 100,000 lines of G-code, it takes more than a minute. So, if you upload a file like this 11 megabyte file, it will take 2 minutes and 20 seconds. For larger files, it would be much faster for you to just use the microSD card to copy from the computer. For the touch screen, when you try to generate the preview frame, it works perfectly with files generated by Lightburn. As those G-code files have a comment line that defines the boundary of the job, the firmware can read this line and start drawing the frame right away. If you only use Lightburn, it won't be an issue. But for other users who use the free Laser Gerbil software to generate G-code, since Laser Gerbil won't add the boundary comment at the beginning of the file, the touchscreen has to load the entire file to calculate the frame. If you are processing a few megabytes or a larger file, it may take a few minutes or longer. However, I found a simple fix. When you generate the G-code file, you actually know how large the working area is. For example, in this photo engraving job, the X is 120 millimeters and the Y is 100 millimeters. I can simply add a comment line at the beginning of the file so the touchscreen can read this line without loading the whole file to draw the preview frame. Anyways, if you are trying to draw a preview frame with a larger file, the screen will still warn you if the file is larger than 1 megabyte. If you use Lightburn or have added the boundary comment line manually, it won't be a problem. Okay. That's all the experience I've had so far with this machine. If you are interested in this Longer RAY5 laser engraver, I put the link down below. I also linked my DIY laser tent, the honeycomb bed, LED lights, and other 3D printer STL files. That's it for this video. If you like this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you'll see something new. See you next week. Without having to connect a USB cable to the computer. Without having to connect a USB cable to the computer. Without having to connect a USB cable to the computer. It has a working area of 4